Good afternoon, everybody. Welcome to Chem 1105 with your host, me, Dr. White. Today, I'm going to be doing a review for test number 1. And before we do that, a quick public service announcement from the management, me, and that is don't forget to hand in labs. Labs are easy points. Shh, don't tell anybody I said that, but you got to hand them in. And a lot of you didn't do lab number 1 yet. You can still hand it in. I'll let you hand it in late, just only one time, but hand it in. You don't need the lab kit for lab number 1. If you don't have the lab kit yet, let me know by email. My email address is in my syllabus, whitek@cod.edu. All right, first of all, let's talk about the test number 1. If you look at the announcement this Wednesday, in a little while, I'll do the review, but I just want to remind you, this Wednesday on the 4th of October, wow, it's already October. Wow, this year went fast, it's going fast. I'll be giving test number 1 online. And what does that mean? That means Wednesday morning around 8 a.m., maybe even earlier, I will send out an email with the password for test number 1 PDF file. Test number 1 PDF file is a password protected PDF file. You'll download from, if you look over on the right, from the assignment area. Now, this is my view. You can't see this yet, but you'll see there's test number 1. And you'll download the PDF file and the periodic table. Please use the periodic table that I provide. Do not go online, that's called cheating, or look in a book. And I'll know because my periodic table has a few little wrinkles that I'll know if you've gone online. So please use that periodic table. You'll download test number 1. Now, if you do not have a printer, take a piece of plain white paper, ruled or unruled, I don't care, and write your answers down for all the questions on test 1. You do not have to rewrite the questions. I'll say that again. You do not have to rewrite the questions. Just write number 1 for question 1, your answer. Now, when you're done, you'll upload as a PDF file test number 1. Don't upload picture files, GIF or other type, because it's really hard for me to grade then with 24 students, 9 picture files per students. So please upload. And if you notice over here, and I also have the files in test number 1 area, assignment area, but you'll see here how to create and upload a PDF file of a test or lab. And I have instructions how to do that. If you don't have a scanner, you can use your cell phone or anybody else's cell phone if you don't have a cell phone. I think by now most people or someone you know nearby has a cell phone. Take pictures and then convert them into a PDF file. Now, I've gotten feedback. I've never used it, but for a number of years now, since COVID started, I've been teaching on Zoom and online. Students have been using Cam Scammer, and it's an app for your cell phone. Now, do not pay anything for Cam Scammer. Use the free version. You don't need all the bells and whistles. Again, if you're going to use Cam Scammer, and a lot of my students have used it and have said it works well, I have my own scanner right up there, so I don't use it. And also, I'm not taking my own test. But anyways, it works well. Use the free version. And when you're done, you'll upload that. Now, it should take you about 45 minutes. If we were face to face, I've given similar test ones in 1105. I've taught 1105 a number of times at COD. If you were taking test one, it would take about 45 minutes to finish if you've done the practice problems. Hopefully you have. Now, since we're online and I'll trust you, if you need up to 3 hours to finish it, doesn't mean when you start, you have to have it uploaded in 3 hours, but total 3 hours, go right ahead. Now, test number one, let me fix something. I don't know why it's doing it. There, we stopped it. All right, test number one will cover material in chapters 1, 2, 3, along with appendix A2 and A4 in your textbook. I've covered these in the videos. You should have watched the videos up today's week. Test one has 100 points, 29 problems, including 7 multiple choice. Dr. White doesn't like all multiple choice tests. I never have given one, never will. And it has 8 pages, including a page with key formulas. And like I said, there'll be a periodic table you'll need for this. You'll need a scientific calculator. I've done a video how to use the Texas TI 30II XIIS and other calculators that are similar. So that's how you do it. Now, I want to show you one more thing that I need to open up. I can find it. Where did I hide it? Oh, I know why. Sorry, hold on. As I've mentioned in my videos, I've cut down in the memorization. You'll see it more in later tests that you need to do in this class. I'm testing your knowledge of chemistry, not your knowledge of chemistry and your memory for the most part. At the end of test one, what you print out, or if you want to just read it off your screen, you'll see on the last page, I have important information. I have these formulas, electron shells, this table, the number of electrons in each shell, this table, and a hint, electron configuration, a statement of how many electrons an atom has in each of its subshells. And that in the past, you would have had to memorize. I'm giving it to you. All right, let's begin our review for test number one. Now, before I do that, I just want to show you real quick. If you go to the course information, click on the lecture folders, you scan down, you'll see the file I just showed you, important information, test number one. And if you scroll down more, you'll see Chem 1105, test one review, both as a Word document, MS Word document, and a PDF file for you to download. And that's what I'll be reading off of right now. So let's begin test number one review. And these are things that you should know. All right, let's go from the beginning. I've started talking about the 4 branches of chemistry. And you should know they are organic, physical, analytical, and inorganic. By the way, organic's the best. I'm an organic chemist. All right, next, we have matter. And the question is, what is matter? Matter is anything that occupies space and has mass. Now, I asked you, and you saw that in my lecture notes for chapter 1, which are also in Blackboard, that you should know key chemical symbols. Now, let's go look at the periodic table. And here's the periodic table you should use that you'll be able to download from test number 1 assignment area. And you need to know, hopefully you've learned them by now, such as H is hydrogen, O is oxygen, and Ag is silver, Au gold, and so on. Now, this periodic table has 103 elements. Guess what? Most of those I have never used or will never use or never considered using or work with. And neither will you. None of us, I will bet, and when I say I'll bet, I know I've already won, will ever use Lawrencium Lr 103. But oxygen you're breathing now, 2 atoms held together, you'll learn about that later, nitrogen, carbon, those are all important ones you should know. And in the video and in the problem set, I give you examples of practice problems. Now, important area I talked about were the three states of matter. That's solid, liquid, gas. You should know it. Solid has definite shape, definite volume. Liquid, indefinite shape, definite volume. And gas, indefinite shape, indefinite volume. So you should know the 3 states of matter are solid, liquid, and gas, and what defines them by shape and volume. Now, when we talk about matter, there are 2 types. There's pure substances and mixtures. And when we talk about pure substances, they're the elements and compounds. And when we talk about mixtures, we have 2 different types of mixtures. By the way, a mixture is when you take 2 chemicals or substances, put them together, and neither one reacts with the other. They keep their same physical and chemical properties, which I won't ask you what is a mixture, but you should know homogeneous mixture, the same throughout, such as the air you're breathing. If you were to take sugar and put it in water and shake it up real good, dissolve it, that would be homogeneous. And heterogeneous, that's when they're separate. It's not the same throughout. Example of that would be an oil vinaigrette salad dressing. I think you've all seen it separate. Or, which I won't do, but if I were to put sand in my water bottle, the sand would all stay at the bottom and the water would be up there, and that would be a heterogeneous mixture. Now, when I talked about compounds, one of the things I did teach you is formulas. And by the way, this is water, and the subscript here tells me I have 2 hydrogen, no subscript is 1, so there are 3 atoms in water. Now, this is sodium chloride table salt, and it has 1 sodium, 1 chlorine, and that tells me there are 2 atoms in sodium chloride. And if you watch my videos, you heard that if you go out to lunch, breakfast, or dinner with a bunch of chemists, one of us will say, will you please pass the NaCl, the salt? And I've done that more than once. Yes, I am a chemist. All right, now one other thing I taught you was, this is magnesium hydroxide. And when you have brackets and atoms inside the bracket, you look at the number here and notice I have one magnesium, but now I have 1 times 2, 2 oxygen, 1 hydrogen times 2, 2 hydrogen. That means there are 5 atoms in magnesium hydroxide. And that's something you should know. One thing I've mentioned, I'll mention again, every question on my test, the concept behind the question that you should learn or should have learned, I've talked about in my videos at least twice, usually a lot more. All right, next we talk about properties of matter. There's physical properties and chemical properties. And physical properties are things you can observe about something, such as my top is black, gold has this color, it's also shiny, you can rub it, that's called a physical property called luster. And chemical properties explain how a substance can change. Gasoline is flammable, water is not flammable. Those are chemical properties. Now, I talked about changes in matter, and there are 2 types of changes in matter. One is a physical change, and one is a chemical change. And a physical change is when a substance undergoes a change in state of matter. In other words, example of a physical change is if you boil water. And that the water goes from a liquid to a gas. And later in the semester, I'll talk a lot more about the concept of what is boiling and how it plays a role in our life. Now, a chemical change is where it shows how substance can change, the ability to change. An example would be iron can rust. You go from iron reacting with oxygen to ferric oxide, which is also known as rust. And the fact that iron can rust is a chemical change that occurs when that does happen. Another example of a chemical change, you can see one here that I got from the Netherlands. I love candles. I got a great collection of hand-dipped candles I got in the Netherlands when I worked for a Dutch company. And I go over there a couple of times a year. And I'd stay in one city I stayed in was Gouda, you know it as Gouda. And when you light a candle, the wax is burning, and that's a chemical change. All right, next I talked about formulas for converting from one temperature scale to another. And here they are. And you should know how to use these. And I did that in the video. There's also practice problems. One thing to remember, for this formula, do the multiplication here before you add the 32. Again, multiply 1.8 times degrees C and then add 32. Now, in this formula, it's important to do what's in the bracket first. Take degrees F and subtract 32, and then divide by 1.8. Again, it's important to do what's in the bracket first. And in my videos for this area, I've done practice problems, and there are also practice problems for you to use to do. Speaking about that, just in case you aren't sure, If you go to Blackboard, click on course information, you'll see recommended practice problem sets and recommended problem set answers. If you do these problems on your own, you will do good on all my tests. All right, next I talked about scientific notation. Scientific notation is a way of easily writing a real big number and a little tiny number. And it's Q some number times 10 to the n power. Q is never less than 1 and never 10 or greater. And know how to convert to scientific notation. Now, I'll give you an example in a second. But remember, if the number is greater than 10, n is positive right here. If the number is less than 1, n is negative. And if I were to ask you to write this number in scientific notation, how do you do that? Well, if there was a decimal, it would be here. You move where the decimal is or would be to the right of the first non-zero number. 1, 2, 3, 4. And zeros at the end, where there's no decimal, you drop. And then how many times did I move it? 4. And that's how you do a number greater than 10. And if I were to ask you to write this number in scientific notation, you do the same thing. Now you do have a decimal, 1, 2, 3. You move it to the right of the first non-zero number. Now lead zeros are dropped. So I'm going to drop these zeros, and this would be 3.751. Hold on one sec. I don't want a gap here. Now, since this number was less than 1, 0.003751, it's times 10 to the minus, and we moved it 3 times 3. And that's how you do scientific notation. Now, next, I talked about a very important area dealing with numbers, and that's significant figures. And you should know how to determine how many significant figures a number has. Now, there are rules. I'll never ask you the rules, but for significant figures, all non-zero numbers are significant. Now, zeros may or may not be significant. That wasn't too helpful. But lead zeros at the beginning of the number are never significant. Confined zeros, those between non-zero numbers, are significant. Now, when we come to trailing zeros, those at the end of a number are significant if a decimal is present in the number. Trailing zeros, those at the end of a number, are not significant if the number lacks explicitly, and this is the important part, explicitly shown decimal point. You should know these rules. I will never ask on the test what are the rules, but I'll expect you to know how to apply it. So you should know how to do now. I'm going to abbreviate, but on a test I would not. I'll type this out. And if we look at the first one, the question is, how many significant figures are in that number. Time out for a water break. And the answer is 4, because all non-zero numbers are significant. Now, if we look at this number, and the question again is, how many significant figures are in that number? Well, all non-zero numbers are significant. So 1 and 5 are 2 numbers. But notice no decimal point. So trailing zeros in this number are not. So the answer is 2 significant figures. And if we look at this one, how many significant figures? Well, the non-zero numbers are significant. So there are 3 of them. Now this 0 is confined between 2 non-zero numbers. So that's significant. So this would also have 4 significant figures. Now, if we look at this number, we have, a decimal point. So trailing zeros with a decimal point are significant. Non-zero numbers are significant. So we have 1, 2, 3, 4, 5, 6. And remember, leading zeros are not significant. And you should be able to do that. Now, when it comes to math, there's a rounding off. And you'll see why we round off significant figures or numbers. And if the first digit to be rounded, to be deleted, when you're rounding off is 4 or less, simply drop that number and all the following digits. If the first digit to be deleted is 5 or greater, then that digit and all following digits are dropped, and the last retained number is increased by 1. So let's take a look at this. Now, if we look at this number, and if you had to round it off to 3 significant figures, this is your first significant, second, third. This is the number you use to round off. That's 4 or less. So you drop this, and the correct answer to round that off to 3 significant figures would be 1.75. And what if you had to round this off to 4 significant figures? Well, the first significant figure you keep is this, and then this is my second, third, fourth. This is the number we use to round off. And is that 4 or less or 5 or higher? And hopefully I'll pick 5 or higher. So I'm going to drop this and anything afterward and increase this in front of it by 1. So to 4 significant figures, that would be rounded off to that. Now, one that's a little tricky, and let me show you this. Let me rewrite it. That's better, 1.99. What if you had to round that off to two significant figures? Well, you keep this, and you use the second nine to round off. That's 5 or higher. So I'm going to drop that and increase this by 1. Well, that becomes 1.0. So, but 1.0 plus 1, this rounds off to 2.0. And that's how you do something like that. Now, when it comes to rounding off, you use that when you do math with significant figures. And there's two types of math areas you will do in my class. And by the way, on test number 1, underneath your name, it will say, please use proper significant figures for all calculated answers. And if you don't, I'll take off 1 point. I'll say that again. On test 1 and also 2, 3, 4 in the final, it will say, but that's down the road. But test 1, underneath your name, it will say, please use proper significant figures for all calculated answers. If you don't, I'll take off a point for any question you don't do it correctly. Now, for multiplication and division, you get the same number of significant figures as the number you multiply and divide that has the fewest significant figures. For multiplication and division, you get the same number of significant figures that of the number you multiply and divide that has the fewest significant figures. And your calculator, and don't forget, I forgot which video I show how to use this kind of calculator, because likes to give out a lot of numbers. Let me show you one. If I were to take this, and what's the answer? And I'll pick up my calculator, turn it on, clear it. And my calculator gives me this number. And that's a lot of significant figures. If you put this down as your answer, I'm going to take off a point because this has 1, 2, 3, 4 significant figures. And this has 1, 2 significant figures. And this is multiplication division, in this case division. So your answer should have the same number of significant figures as the number you multiply and divide that has the fewest, 2. So we round this number off to 2 significant figures, keep the 3, keep the 1, use the 7 to round off, and that's 5 or higher. So I'm going to drop all this, increase this by 1, and the correct answer for this problem using significant figures is that. Now, I talked briefly about addition and subtraction, but on test 1, there's no addition or subtraction. Now, when you're using exact numbers, they're not to be considered when determining numbers of significant figures of a math operation. An exact number is if you count a number of items or part of a definition. All right, next I talked about the periodic table, and you should know group names. The alkali metals, the alkaline earth metals, the halogens, and the noble gases. And you should also know examples of metals. Let's go to the periodic table. Not hydrogen, but lithium, sodium, and potassium are the alkali metals. So are the other ones, but I didn't ask you to learn like cesium or francium. All right. In the second column under the number 2, magnesium and calcium are the alkaline earth metals that you should know. Now, I didn't ask you to learn strontium, SR, or the others, but those two I did ask you to learn. Now, all the way over to the right, the second to last column with underneath the number 7 is fluorine, chlorine, bromine, iodine. Those are the halogens. And all the way over to the right are the noble gases, helium, neon, argon, krypton, xenon. By the way, in our universe, krypton is not a green solid, but a colorless gas, and it will not kill Superman. At least I hope not. And you should know those. All right. Now, next, we got some chemistry. I talked about the atom. That's the smallest particle of an element. And the atom is made up of 3 subatomic particles that you should know. An electron, which has a negative charge, a proton, positive charge, neutron, no charge. You should know an electron has a negative charge, a proton, positive charge, neutron, no charge. Now, when it comes to where are those subatomic particles, the nucleus of the atom, which is the center of the atom, contains only protons and neutrons. You should know that. And you should know, I talked about it in the video, Rutherford's gold foil experiment helped elucidate the nucleus of an atom. By the way, elucidate means figures out or clarifies. Now, when we come to the protons of an element, that is found by the atomic number of that element. Now, all atoms of elements have a net zero charge. All atoms of elements have a net zero charge. And the atomic number equals the number of protons, which have plus charges, then that also equals the number of electrons, which have a negative charge. And where do you find this number? From the periodic table. In the upper corner, that right corner of the periodic table, you'll be using and downloading from, it's also available in the lecture section of Blackboard. That gives you how many, that's the atomic number, and that gives you the number of protons and electrons. So carbon, my favorite element, I'm an organic chemist, has 6 protons, 6 electrons, because here's the atomic number. Ooh, bromine, Br, has 35 protons and 35 electrons. And argon, which I worked with a lot in grad school, working to get my PhD, I used a lot of argon gas, has 18 electrons, 18 protons. The atomic number, this number, gives you how many electrons and protons an element has. Now, if the protons and neutrons are in the nucleus, the center of the atom, which is very dense, where are the electrons? They're all around the nucleus of an atom in the shells and subshells of the atom. Now, you should know, that, well, I'll give this to you, but still you should realize what this means, that the electron shells have the shell names, very difficult to remember, 1, 2, 3, and 4. And the subshells, each shell, the shell 1 has 1 subshell, 2, 2, and 3, 3. And what you should also know is This shell 1 is the lowest energy, and 4 in this table is the highest energy. Now, each shell has subshells, and they're named S, P, D, and F. And in real life, they're lowercase, but it's easier for you to see uppercase. And shell S has maximum number, and I think I have this corrected where I have maximum put in number of electrons at 2. Shell P, 6 maximum, D, 10, F, 14. Now, you always designate a subshell by a number and a letter. And the first subshell is 1s. Now, once again, for this table, for those subshells, S is the lowest energy subshell, and F is the highest energy subshell. Now, one of the important things that helps chemists understand different aspects of elements and how they react in their chemistry and physical properties are where are the electrons. And here we use there are 2 different ways. In this course, I'm only teaching the electron configuration. And that's a statement of how many electrons an atom has in each of its subshells. Remember, a subshell is designated by a number and a letter. And the electron configuration just deals with numbers and letters. Now, if we look at the periodic table, and if I were to draw the electron configuration of carbon, first of all, you have to know how many electrons carbon, chemical symbol C, has, 6. And say on Wednesday, I asked you draw the electron configuration for, say, a couple of them, and say 1 is carbon. We have to know carbon has 6 electrons, and we got that from the atomic number. And the first shell is 1. And if we go back to that table, you always put electrons in the, can you see it right here? That didn't work out too well. Shell 1 always, that's the first, you always add electrons to the lowest energy shells and subshells. Now, shell 1 has 1 subshell, and its lowest subshell is 1s. And you can put a maximum of 2 electrons in there. So let's do that. Well, I have 6. I've taken care of 2. I have 4 more to go. And if we look at this table, shell 1 has 1 subshell. We filled it up with 2 electrons. We next go to shell 2, which has 2 subshells. Now, the first subshell in shell 2 is 2s. Always fill the lowest energy shell and subshell. And 2s, you can only put 2 electrons. So I will. Well, 2 plus 2 is 4. I've got more electrons to go. Well, how many subshells does shell 2 have? And the answer is 2. And the first one was S, and the next one is, or 2S, and the next one is 2P. Now in 2P, I can put a maximum of 6 electrons, but for carbon, we have 6 minus 4. We have 2 more electrons to go, so I'll do 2P, and I'll put in my 2 electrons. And the electron configuration for carbon is 1s2, 2s2, 2p2. Now, keep this a secret. For my class, you only have to know how to do electron configuration up to magnesium atomic number 12. For my class on test 1 and the final, you only have to do electron configuration up to 12, magnesium. Why? Because when you get down to the others, there are changes in the rules and you got exceptions, and there are better things I'd like you to learn in my course this semester. So that's my gift to you. All right, the next thing I talked about are the valence electrons. And you should know the valence electrons are the outermost electrons of an element. The valence electrons, by the way, these are the most important electrons in an element. Dr. White loves valence electrons. And they are, you should know, they're the outermost electrons of an element. And how do you find how many valence electrons an element have? You look at the top of my periodic table. Now remember, excuse me, don't remember I coughed and take a water break. Now remember, the maximum number any element can have of valence electrons is 8. It says it right here. Now, in the past, when I went to school, we were taught Roman numerals. And a couple of years ago, I found out they don't teach that in school anymore. So if you look at this older periodic table, you see the Roman numerals, but I also have the numeric equivalent in case you don't know your Roman numerals. And if I were to ask, how many valence electrons does potassium have? Well, potassium atomic symbol K, look at the top, it has 1 valence electron. My favorite, carbon, chemical symbol C, has 4 valence electrons. Chlorine, chemical symbol Cl, has 7, and neon has 8. And you should know how to do that. And with that, I'm done with the review. First of all, let me ask, for those of you who are here, do you have any questions? Yep, my speaker's on. When I first started doing Zoom, I forgot to turn my amplified speaker up there on. What'd you say? All right, let me review again real quick. On Wednesday at 8 a.m. or earlier, sometimes I usually start earlier, but at least by 8 a.m., you will get an email with the password for test number 1 PDF file, which you will download from the assignment area of Blackboard. You can't see it now, but about 5 or 6 a.m., it'll be visible to you. And by 8 a.m., I'll send you out that password. You will either print out, download and print out test number 1 and write on it. Or if you don't have a printer, you can open it up on your screen, whatever it is, your computer, your tablet, you can even your cell phone, because it's a PDF file, and you'll take test number 1. If you don't have a printer like I have there, you can just write out the answers on a piece of paper. Be sure to put your name on there. By the way, either way, when you write your answers, make sure I can read them. You don't want me guessing, what the heck is that? Because I can guess wrong. Now, after you finish doing your test number one, you'll upload it as a PDF file to the assignment area of Blackboard. If you have a scanner, most like I do, scanners will make a PDF file. If you don't, take your cell phone, take pictures of each page of your answer, and on Blackboard, I have a file teaching you how to make a PDF file from cell phone pictures. And do not upload cell phone pictures to the assignment area. I'll take off points. And test number one should take you about 35, 40 minutes to finish if you've done the practice problems, but take up to 3 hours if you really need it. You'll have, in case you're working at 8 a.m. Wednesday morning, you'll have until I think 4 or 6 p.m. On Thursday to upload your answers for test number one. And then I will, by Sunday or earlier, put your test scores, graded test scores, in Blackboard. I'll send out an announcement and such. By Sunday, 1 p.m. or earlier, I will also to each of you send out individual email with each, how many points you got for each answer you put down on test number one. Before I forget, before you upload that PDF file, make sure you've got all your pages of your answers. I've had students, they forgot to upload question and answers, say 5 through 8. I've got to go track them down, and please make sure before you upload it, everything is included, all your answers. Now, next Monday, a week from today, I will have maybe about at 4 p.m., I'll have a Zoom meeting like this one, and I'll go through all the answers for test number one. I'll record it like this one. I'll post it as a video, but I'll post it as a private video on my YouTube channel. I'll send out an email with the link to that private one. I just don't want to have test one open to the whole world answers. And you should check. A student should never be penalized for a grading error I make on a test. I usually don't, but the last time I checked, I don't walk on water unless it's frozen. Even then I stay off. In other words, I'm not perfect. I haven't met a perfect person yet. So with that, I'll wish you good luck. If you need help, come to my office hour tonight. Come to my office hour Wednesday night. Also, if there's a question about any problem, remember in my world, there's no such thing as a dumb question, including while taking a test. If you're not sure, email me or come Wednesday night to my office hour. With that, if there are no anybody last minute questions, well, thank you for coming and thank you for watching this video. Good luck. Hopefully you won't need luck on test number one this Wednesday. And with that, I'll say gang gesund. Goodbye now. I stole that from Granny and the Beverly Hillbilly. Bye now.